Coming to the first problem, find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1 and x is equal to 2. So let us see the solution. So the given polynomial is 5x minus 4x square plus 3. So the value of the polynomial at x is equal to 0 is 5 times of 0 minus 4 times of 0 square plus 3, which is equal to 0 minus, this is also 0 plus 3, which is equal to 3. Therefore, value of the polynomial at x is equal to 0 is 3. Next, the value of the polynomial at x is equal to minus 1 is 5 times of minus 1 minus 4 times of minus 1 square plus 3, which is equal to minus 5 minus 4 plus 3. This is equal to minus 4 minus 5 is minus 9 and plus 3. This is equal to minus 6. Therefore, the value of polynomial at x is equal to minus 1 is minus 6. Next one is the value of polynomial at x is equal to 2 is 5 times of 2 minus 4 times of 2 square plus 3. 5 times of 2 is 10 and 4 times of 2 square is 4 plus 3, which is equal to 10 minus of 16 plus 3. This is equal to 13 minus 16, which becomes minus 3. Therefore, the value of polynomial at x is equal to 2 is minus 3. Moving on to the second problem, find p of 0, p of 1 and p of 2 for each of the following polynomials. We are being given 4 polynomials. P of y is equal to y square minus y plus 1, p of t is equal to 2 plus 2 t square minus t cube, p of x is equal to x cube, and p of x is equal to x minus 1 into x plus 1. So the first bit is given polynomial is p of y is equal to y square minus y plus 1. So we need to find p of 0, p of 1 and p of 2. This is done. P of 0 can be obtained by substituting 0 in place of y, which gives 0 square minus 0 plus 1, which is 0 minus 0 plus 1. This gives 1. Therefore, p of 0 is equal to 1. Next, p of 1 is equal to 1 square minus 1 plus 1. 1 square is 1 minus 1 plus 1. 1 minus 1 is 0. 0 plus 1, which is 1. Therefore, P of 1 is equal to 1. P of 2 is equal to 2 square minus 2 plus 1. 2 square is 4 minus 2 plus 1. 4 minus 2 is 2 plus 1, which becomes 3. Therefore, P of 2 is equal to 3. Going on to the second bit, which is P of t is equal to 2 plus t plus 2t square minus t cube. So let us first find P of 0. This is equal to 2 plus 0 plus 2 times of 0 square minus 0 cube, which is equal to 2 plus 0 plus 0 minus 0, which is equal to 2. Therefore, P of 0 is equal to 2. P of 1, which is equal to 2 plus 1 plus 2 times of 1 square minus 1 cube. 2 plus 1 is 3 plus 2 times of 1 square is 1 and 1 cube is also 1. 3 plus 2 minus 1. So this becomes 5 minus 1, which is 4. Therefore, P of 1 is equal to 4. And next one is P of 2, which is 2 plus 2 plus 2 times of 2 square minus 2 cube. This is equal to 2 plus 2 is 4 plus 2 times of 2 square is also 4 minus 2 cube is 8. P of 2 is equal to 4 plus 2 times of 4 minus 8, which is equal to 4 plus 2 times of 4 is 8 minus 8, which is equal to 4 plus 0, which is equal to 4. Therefore, P of 2 is equal to 4. Moving on to the third bit, which is P of x is equal to x cube. So let us first find P of 0. This is obtained by substituting the value of 0 in place of x, which is equal to 0 cube, which is 0. Therefore, P of 0 is 0. So let us find P of 1, which is equal to 1 cube. So 1 cube is 1. Therefore, P of 1 is equal to 1. Next, P of 2 is found by substituting the value of 2 in the place of x. Therefore, P of 2 is equal to 2 times cube. We know that 2 power 3 called 2 cube is 8. Therefore, P of 2 is equal to 8. Moving to the fourth bit, which is P of x is equal to x minus 1 multiplied by x plus 1. So let us first find the value of P of 0. So substituting the value of 0 in place of x, we get 0 minus 1 multiplied by 0 plus 1. 0 minus 1 is minus 1 and 0 plus 1 is plus 1. Minus 1 multiplied by 1 is minus 1. Therefore, P of 0 is equal to minus 1. And the value of P of 1 is equal to, substituting the value of 1 in the place of x, we get 1 minus 1 multiplied by 1 plus 1, which is equal to 1 minus of 1 is 0 multiplied by 2. 0 multiplied by 2 is 0. Therefore, P of 1 is 0. So, the value of P of 2 can be found by substituting the value of 2 in the place of x, which gives P of 2 is equal to 2 minus 1 multiplied by 2 plus 1. We know that 2 minus 1 is 1 and 2 plus 1 is 3. 1 multiplied by 3 is 3. Therefore, the value of P of 2 is equal to 3. Moving to the third problem, verify whether the following are zeros of the polynomial indicated against them. So, moving on to the solution, let us first define what is the zero of a polynomial. So, the zero of a polynomial is defined as the value of the variable at which the polynomial becomes 0. So let us take the first bit, which is P of x is equal to 3x plus 1 provided x is equal to minus 1 by 3. The given polynomial is in the form of 3x plus 1 and the variable here is x. So let us substitute the value of minus 1 by 3 in the place of x, which is P of minus 1 by 3 is equal to 3 times of minus 1 by 3 plus 1. So 3 and 3 gets cancelled and we get minus 1 plus 1, which is 0. That is, P of minus 1 by 3 is 0. That means x is equal to minus 1 by 3 is the 0 of the polynomial. Hence, it is true. It is true that x is equal to minus 1 by 3 is the 0 of a polynomial. So the second bit is P of x is equal to 5x minus 5 provided x is equal to 4 by 5. So let us substitute the value of 4 by 5 in place of x. We get P of 4 by 5 is equal to 5 multiplied by 4 by 5 minus 5. 5 and 5 gets cancelled. We get 4 minus 22 by 7 because the value of pi is 22 by 7, which is not equal to 0. Therefore, we say that P of 4 by 5 is not equal to 0. Hence, x is equal to 4 by 5 is not a 0 of the given polynomial. So let us move to the third problem, which is P of x is equal to x square minus 1 provided x is equal to plus 1 and minus 1. First, let us take x is equal to 1, which is P of 1. Substituting the value of 1 in the place of x, we get 1 square minus 1, which is 1 minus 1, that is equal to 0. And substituting the value of x is equal to minus 1 which is p of minus 1, which is minus 1 whole square minus 1. That becomes 1 minus 1, which is also 0. Therefore, by the definition, we can say that x is equal to 1 and x is equal to minus 1 are zeros of the given polynomial. Coming to the fourth bit, which is p of x is equal to x plus 1 multiplied by x minus 2. So given that x is equal to minus 1 and x is equal to 2. So let us first substitute minus 1 in the place of x. That becomes minus 1 and plus 1 is 0. Minus 1 minus 2 is minus 3. 0 multiplied by anything becomes 0. Therefore, p of minus 1 is 0. That means minus 1 is a 0 of the given polynomial p of x. Next, let us substitute x is equal to 2. That is, p of 2 is equal to 2 plus 1 multiplied by 2 minus 2, which is 3 multiplied by 0. That becomes 0. Therefore, p of 2 is equal to 0. So we can say that p of minus 1 is 0 and p of 2 is equal to 0. That is, minus 1 and 2 are the zeros of the polynomial. Next, coming to the fifth bit, which is given as p of x is equal to x square and x is equal to 0. So let us substitute the value of x, which is 0. Therefore, it becomes p of 0 is equal to, in the place of x, if I substitute 0, it becomes 0 square, which is 0. That is, p of 0 is equal to 0, which means x is equal to 0 is a 0 of the polynomial. Next, sixth bit, which is p of x is equal to L times x plus m, given that x is equal to minus m by L. So let us first substitute x is equal to minus m by L. That becomes p of minus m by L is equal to L multiplied by, in place of x, if we substitute minus m by L, we get L multiplied by minus m by L plus m. L and L gets cancelled. Then this becomes minus m plus m, which is 0. That is, p of minus m by L is equal to 0. Therefore, we can say that x is equal to minus m by L is 0 of the given polynomial. Next, let us see the seventh bit, which is given as p of x is equal to 3x square minus 1, given that x is equal to minus 1 upon root 3, comma 2 upon root 3. So let us first substitute x is equal to minus 1 by root 3. That becomes p of minus 1 by root 3 is equal to 3 times of, in place of x, I substitute minus 1 by root 3, which becomes 3 multiplied by minus 1 by root 3 whole square minus 1. Then this becomes 3 multiplied by minus 1 square is 1 and root 3 square is 3. This is because root 3 square, this can be written as 3 power 1 by 2 whole square. 2 and 2 gets cancelled. This becomes 3 power 1, which is 3. So here 3 and 3 gets cancelled and this becomes 1 minus 1, which is 0. Therefore, we can say that x is equal to minus 1 by root 3 is a 0 of the given polynomial. Now let us substitute x is equal to 2 by root 3, which gives p of 2 by root 3 is equal to 3 times x square becomes 2 by root 3 whole square minus 1. I have already mentioned in the previous problem, root 3 square is equal to 3 power 1 by 2 whole square, which is 3 power 1, nothing but 3 only. This is equal to 3 times 2 square is 4, and we can see root 3 square is 3 minus 1. 3 and 3 gets cancelled and this becomes 4 minus 1, which is 3. Therefore, I can say that p of 2 by root 3 is equal to 3, which is not equal to 0. Then we can say that p of 2 by root 3 is not equal to 0. Hence, x is equal to 2 by 3. 2 by root 3 is not a 0 of the given polynomial. Coming to the 8th bit, which is p of x is equal to 2x plus 1, given that x is equal to 1 by 2. So let us substitute x is equal to 1 by 2 in the given polynomial, which becomes p of 1 by 2 is equal to 2 times of 1 by 2 plus 1. 2 and 2 gets cancelled and we get 1 plus 1, which is 2. Therefore, p of 1 by 2 is equal to 2, which is not equal to 0. By the definition, we can say that x is equal to 1 by 2 is not a 0 of the polynomial. This is because p of 1 by 2 is not equal to 0. Moving on to the 4th problem, find the 0 of the polynomial in each of the following cases. So the first polynomial is p of x is equal to x plus 5, and the second one is p of x is equal to x minus 5. Third one is p of x is equal to 2x plus 5. So in order to find the 0 of the polynomial, we need to equate the given polynomial p of x is equal to 0. So if we equate p of x is equal to 0, we can find the value of x, which is nothing but the 0 of the polynomial. So let us see the first bit, which is p of x is equal to x plus 5. The given polynomial p of x is equal to x plus 5 must be equated to 0. That becomes p of x is equal to x plus 5 is equal to 0. X plus 5 is equal to 0. So transposing plus 5 to right hand side, we get x is equal to 0 minus 5, which is minus 5. That means x is equal to minus 5, which is nothing but the 0 of the polynomial. Now let us see the second polynomial, which is p of x is equal to x minus 5. So for finding the 0 of the polynomial, we must equate the given polynomial to 0, which is p of x is equal to 0. Given that p of x is equal to x minus 5. So we can write x minus 5 is equal to 0. That implies, let us transfer the minus 5 to right hand side. This gives x is equal to 0 plus 5, which is nothing but x is equal to 5. Therefore, x is equal to 5 is the 0 of the given polynomial. Now, let us see the third bit, which is p of x is equal to 2x plus 5. In order to find the 0 of the polynomial, we need to equate the given polynomial to 0, which is p of x is equal to 0. That gives 2x plus 5 is equal to 0, which gives 2x is equal to minus 5, which implies x is equal to minus 5 by 2, which is the 0 of the polynomial. Moving on to the fourth bit, which is p of x is equal to 3x minus 2. So first let us equate the given polynomial p of x is equal to 3x minus 2 to 0. P of x is equal to 0. That implies 3x minus 2 is equal to 0. So transposing minus 2 to RHS, we get 3x is equal to 0 plus 2. That is 3x is equal to 2. That implies x is equal to 2 by 3. Therefore, x is equal to 2 by 3 is the required 0 of the given polynomial. Now let us see the fifth bit, which is given as p of x is equal to 3 times x. Let us equate the given polynomial p of x to 0. We get p of x is equal to 3x is equal to 0, which gives 3x is equal to 0. That implies x is equal to 0 divided by 3, which is 0. Therefore, we can say that x is equal to 0 is the required 0 of the given polynomial. Now let us see the sixth bit, which is given as p of x is equal to ax provided a not equal to 0. So a is a number which is not equal to 0. So let us first equate the p of x is equal to 0, which gives a times x is equal to 0. Now we can judge that a is not equal to 0 because it is mentioned in the question. So x must be surely equal to 0 because a not equal to 0. Therefore, x is equal to 0 is the required 0 of the given polynomial p of x. Moving on to the seventh bit, which is given as p of x is equal to cx plus d. C is not equal to 0 and c comma d are real numbers. So first equate the given polynomial p of x is equal to 0. That gives cx plus d is equal to 0, which gives, transposing the plus d to right hand side, we get Cx is equal to 0 minus d. That gives Cx is equal to minus d. Transposing C to RHS, we get x is equal to minus d upon C. Therefore, x is equal to minus d by C, which is the zero of the polynomial.